Dear students, welcome to the Tech Nirvan channel. In this video, we are going to study about logic gates. You must be using mobile and computers nowadays. These all devices works on digital circuits. So the digital circuits works on the digital logic, that is 0 and 1, and the fundamental building block of any digital circuit is the logic gates. So we will going to study the basic logic gates in this video. The logic gates are nothing but the electronic circuits that can be used to implement the most elementary logic expressions, which are known as Boolean expressions. Logic gates are the most basic building block of the combinational logic. So basically, there are three basic logic gates. The names are OR gate, AND gate, and NOT gate. So we will study these three gates in this video. The other logic gates that are derived from these are NAND gate, NOR gate, exclusive OR gate, and exclusive NOR gate. We will study about them in another video. So let us start. To understand the logic gates, we must know some fundamental principles. One of them is positive and negative logic. So the digital circuits works on the logic 0 and logic 1. These are the binary variables. So all the digital devices works on the binary and logic 0 and logic 1. So these logic states in digital systems such as computer are represented by two different voltage level or current levels. So the physical significance of logic 0 and logic 1 is what? It is voltage and current level. So if more positive of the two voltage or current level represents 1 and the less positive of the two levels represents a logic 0, then such kind of logic system is called positive logic system. Once again, the logic 0 and logic 1 are the fundamentals of any binary system which works for the digital system like computer and mobile. So the realization of the logic 0 and logic 1 is in terms of the voltage and the current level. So the physical realization of digital circuits is logic gates, and the realization of their logic levels means logic 0 and logic 1 is in terms of voltage and current level. So in case of positive logic system, the more positive of two voltage or current level represents 1 and the less positive of the two levels represents logic 0. Reverse of that, if the more positive of the two voltage or current levels represents a logic 0, then less positive of the two levels represents a logic 1, and such kind of logic system is called negative logic system. So basically there are two types of logic system, positive logic system and negative logic system. In case of positive logic system, the higher the value of the voltage or current which represents logic 1 and the lower value of the voltage or current represents logic 0. In case of negative logic system, higher value of the voltage or current represents logic 0 and lower value of the voltage or current represents logic 1. So to understand this, let us take the value of the voltage 0 volt and plus 5 volt. So in case of positive logic system, the 0 volt will represent logic 0 and plus 5 volt will represent logic 1. In case of negative logic system, 0 volt will represent logic 1 and plus 5 volt will represent logic 0. Okay. To more clarify this, let us take to another voltages 0 volt and minus 5 volt. In this case, plus 5 volt is higher than 0 volt. That's why in positive logic system, plus 5 volt represents logic 1 and 0 volt represents logic 0. In this case, we have negative voltage, minus 5 volt. So minus 5 volt is the lower voltage compared to 0 volt. So in case of positive logic system, the 0 volt will represent logic 1 and minus 5 volt will represent logic 0. In case of negative logic system, 0 volt will represent logic 0 and minus 5 volt will represent logic 1. So to remember, in case of positive logic system, higher value of the voltage or current will represent logic 1 and lower value of voltage and current will represent logic 0, and reverse of that, that is higher value of the voltage or current will represent logic 0 and lower value of the voltage or current will represent logic 1 in case of negative system. So in all our further discussions, we will use positive logic system unless otherwise it is specified. So normally everywhere positive logic system is preferred. Now truth table. So to understand the working of logic gates, we require to develop a truth table. So what is truth table? So truth table lists all possible combination of input binary variables and corresponding outputs of a logic system. So if you take any logic system, there must be some binary inputs and outputs. So all the combination of input and output are represented in terms of tabular form and it is called truth table. So when the number of input binary variables is only 1, then there are only two possible inputs, that is 0 and 1. If the number of inputs are 2, then there can be 4 possible inputs, 0, 0, 0, 1, 1, 0 and 1, 1. So this is the example. This is some logic system with input A and B and the output is Y. So based on this logic system, we can develop truth table like this. A and B are input, Y is output, number of inputs are 2. That's why we will have combinations like this 0, 0, 0, 1, 1, 0 and 1, 1. So these are the combination of input, and for each combination based on this logic we will get output 0, 1, 1, 1. So this is our truth table and this is the example of logic system. So for 3 input variables, the possible combinations would be like this 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So from this we can say that for n number of binary inputs of any logic circuit, the truth table will have 2 raised to n possible input combinations. So for single input we will have 2 raised to 1, 2 combinations. For 2 input 2 raised to 2, 4 combination, and for 3 inputs 2 raised to 3, 8 combinations, like that. So truth table is the table to understand the input and output of any logic system. Now logic gates. So as I told you, logic gate is the most basic building block of any digital system. It can be a mobile, computer or any of your digital devices. So each one of the basic logic gate is a piece of hardware or an electronic circuit. So if you try to understand physical realization of logic gates, it is an electronic circuit, and that can be used to implement some basic logical operations. While laws of Boolean algebra could be used to do manipulation with the binary variables and simplify logic expressions, these are actually implemented in digital system with the help of electronic circuit, and it is called logic gates. So we can say this as a definition of the logic gate. So logic gates are constructed from the fundamental electronic devices like diode, transistors, resistors, and MOSFETs. And such circuits works logically, and based on that logic they give output. So if there is OR logic, the output of the circuit would be accordingly. In case of AND logic, output would be accordingly, and in case of NOT logic, output will be accordingly. So we will study these fundamental or basic logic gates and their operations, OR, AND, and NOT. So first we will understand OR gate. So this is the symbol for the OR gate. This is two input OR gate. A and B are input and X is the output. And this is the symbol which represents OR gate. So the equation for the OR logic can be written like this. X is the output, A and B are the input. So X is equal to, here is the plus sign which indicates OR operation. X is equal to A or B. We can read like X is equal to A or B. So in mathematics, plus indicates addition. In case of digital circuits or in case of logic gates, the meaning of plus is OR operation, right? The plus sign stands for the OR operation. So the OR gate performs OR operation, and the logic for the OR gate is like this. The OR operation produces result 0 only when all the input variables are 0. Again, OR operation will produce result 0 only when all the input variables are of 0 logic. The OR operation will produce result 1 when any of the input would be at logic level 1. So from this logic we can construct truth table for the OR operation of these two input OR gate like this. A and B are input, X is the output. Two inputs are there, that's why possible combination would be 2 raised to 2, that is 4, and those are 0 0, 0 1, 1 0 and 1 1. Now based on this logic we can say that if all the inputs are 0, only then we will get output as a 0. Otherwise, in all remaining cases, if any of the input is 1, then we will get output 1. So this is the OR gate. Remember that if all inputs are 0, then and then only we will get output 0. Otherwise, if any of the input is 1, we will get 1 as the output of the OR gate. So OR gate is a logic circuit with 2 or more input and single output. So output will be always 1 and inputs can be 2 or more. So this is the example of 3 input OR gate. A, B and C are the inputs. X is the output. So based on the logic of the OR gate, we can develop this truth table. A, B, C are input. There are 3 inputs. That's why 2 raised to 3 means 8 input combinations. These are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. If you want to remember this, we will write 0 4 times in A, then 1 4 times, then 00 11 00 11, and in third case 0 1 0 1 0 1 0 1. So from this you can remember the combinations. So based on the logic of the OR gate, if all the inputs are 0, A, B and C all are 0, then and then only we will get 0 as the output. If any of the input is 1, here we have 1 in C, here we have 1 1 1, in this case also we have 1, in this case also we have 1 as input. So in all the cases we will get output as 1. Again, these are not the values. 0 and 1 are not the values, those are the logical states. This is OR gate with 4 input and Y is the output. ABCD are input and Y is the output. Y is equal to A or B or C or D. Now AND gate. AND gate is a logic circuit similar to OR gate, having 2 or more inputs and 1 output. In case of OR gate, we are using mathematical symbol plus. In case of AND gate, we are using mathematical symbol dot or symbol of the multiplication. Mathematically, plus is the symbol of the addition, and digital logic, or in case of gates, plus indicates OR operation. Mathematically, dot or cross or the symbol of multiplication indicates AND operation. Okay, so for AND operation we are using symbol of the multiplication, and we can read this like this: X is equal to A and B. So there is an AND operation between variable A and B. So this is the symbol for the AND gate. We have 2 different symbols. OR gate is like this and AND gate is like this. So based on the number of input, we can connect the inputs and there is a single output. So this is symbol for the AND gate. There are 2 inputs, A and B, and X is the output. Now the logic of the AND operation is like this. AND operation produces a result of 1 only for the single case when all the inputs are 1. Again, when all the inputs of the AND gate are 1, then and then we will get 1 as an output. The output is 0 for any case where 1 or more inputs are 0. So based on these 2 logical conditions, OR gate works. So for this OR gate, we can develop truth table like this. We have input A and B, that's why 2 raised to 2 combinations, that is 4, and those combinations are 0 0 1 1 in case of A, and in case of B 0 1 0 1. So here both the inputs are 0, that's why output is 0. Here one of the input is 0, that's why output is 0. Here also one of the input is 0, that's why output is 0. Only in this case all the inputs are 1, and that's why we are getting output 1. Again, the AND gate is having 2 or more input. So this is the AND gate with 3 inputs, A, B and C, and X as the output. As there are 3 inputs, we have 2 raised to 3 means 8 input variables, combinations. Input variables are 3, A, B and C. We will develop truth table like this. If any of the input is 0, in that case we will get output as a 0. And if all the inputs are 1, then and then we will get output as a 1 in case of the AND operation. Now this is interesting. If we interpret the basic definition of OR and AND gates for a negative logic system. Then we have an interesting observation. We can find that OR gate in a positive logic system is AND gate in negative logic system, and a positive AND is a negative OR. Let us try to understand this. So this is OR gate. For OR gate, we will take positive logic system and negative logic system. So in case of positive logic system, we have input A, B, output X. Negative logic system, input A, B, output X. And we have two voltage level, 0 volt and plus 5 volt. Okay. So in case of positive logic system, what will happen? 0 means 0 volt, 0 means 0 volt, 0 volt, plus 5 volt, plus 5 volt, 0 volt, plus 5 volt and plus 5 volt. So these are our inputs, and we will get output as 0 volt and plus 5, plus 5 and plus 5 volt. So this is positive logic system. In case of negative logic system, for 0 logic, we will have plus 5 volt. So this is plus 5 volt, plus 5 volt, plus 5, 0, 0, plus 5, 0 and 0. So this is plus 5, 0, 0, 0 volt. So this is positive logic system, negative logic system, and this is table for the OR gate. Now let us develop same table for AND gate. So in case of AND gate, let us take positive logic system. A, B are input and X is our output. So our inputs are 0, 0 means 0 volt, 0 volt, 0 volt, plus 5 volt, plus 5 volt, 0 volt and plus 5 volt, plus 5 volt. This is positive logic system. In case of positive logic system, 0 volt is 0 and plus 5 volt is 1. So here 0, 0, 0 volt and plus 5 volt. In case of negative logic system, what will happen? A, B, and X. In case of negative logic system, we have logic 0 as plus 5 volt, logic 0 as plus 5 volt, logic 1 as 0 volt, 0 volt, plus 5 volt, 0 volt, and 0 volt. So in output, we have logic 0 means plus 5, plus 5, plus 5, and 0. From this, we will understand this. Okay, we have OR gate in positive logic system and AND gate in negative logic system. Both are same. So let us try to understand OR gate in positive logic system. So OR gate in positive logic system, we have 0, 0, 0, 0 plus 5, plus 5, 0, plus 5, plus 5. So 0 plus 5, plus 5, plus 5. OR gate in positive logic system, AND gate in negative logic system. So negative logic system, we have 0, 0, 0. Then all other cases we have plus 5, plus 5. So this is connected with this. Then 0 plus 5, output plus 5. Here also 0 plus 5, output plus 5. Then plus 5, 0, output plus 5. And plus 5, plus 5, output plus 5. Plus 5, 0, output plus 5, plus 5, plus 5, output plus 5. So both the truth table are same. Same way, positive logic of AND gate. Okay, AND gate having positive logic is similar to OR gate having negative logic. So remember this 0 0 0 0 plus 5 0 and plus 5 plus 5. We have 3 0, and when both the inputs are plus 5 then output is plus 5. So same truth table would be for OR gate having negative logic. When both input are plus 5, output is plus 5. When any of the input is 0, output is 0. So we can say that OR gate in negative logic system is same as AND gate in positive logic system. OR gate in positive logic system is same as AND gate in negative logic system. So this is quite interesting observation. Now the third basic gate is the NOT gate. So NOT gate is one input and one output logic circuit. So input is always 1, output is always 1, and output is always complement of the input. So the symbol is like this. Symbol is like diode with circle. Input is always single input, output is always single output. So always there is single input variables, means we will have 2 raised to 1 equal to 2 input combinations. So if the variable 1 is subject to NOT operation, the result x can be expressed as x is equal to a prime or a bar. We can write like this, a prime or a bar. So this indicates NOT or invert operation. Okay, prime or bar indicates NOT or inverse operation. We can read like this, x equals the inverse of a, or x equals the complement of a. NOT operation is also referred as the inversion or complementation. So it inverts the input or complements the input. So the input is 0, output of the NOT gate will be 1, and the input is 1, output of the NOT gate will be 0. So truth table would be like this. If the input is 0, output is 1, input is 1, output is 0. Okay. So these three were our basic building block of the digital circuits. They are OR gate, AND gate and NOT gate. All the digital circuits are based on these three gates. These are the fundamental building blocks. They perform three different operations: AND operation, OR operation and NOT operation. So for this video we will keep to these three gates. In another video I will show you remaining the gates which are utilized in digital circuits. Keep watching my video. If you have not subscribed my channel, please subscribe it, and don't forget to like the video, and please comment if you have any query in the comment section. Thank you.